This is lesson 12, surface area of a cylinder. And before we do any questions, I thought it'd be worthy to go through how we actually generate the formula for the surface area of a cylinder. Mainly because it's got this curved part and we're not used to working out the area of a curved part before. So here's our cylinder. Now the dimensions of a cylinder, well, there are only two we need to be concerned with, and that's the height, okay, and the radius of the circle which forms the cylinder. Now, what we like to do is we like to get a pair of scissors and cut our cylinder open into a net. So let's imagine if we cut down here and then cut around the circle and cut around the circle and we unwrapped it, it would start to look like this. And you notice that as soon as we unwrap the curved part, it becomes a rectangle. Okay, so essentially the surface area of a cylinder is a circle at the top, a circle down the bottom, and a rectangle for the curved part. So these formulas, or these areas, we could find with basic formulas. We just need to work out the dimensions. So for a circle, that's fairly straightforward. That's just pi r squared, and this circle is pi r squared as well. The height of the rectangle, or the width of the rectangle, is h. Now the length of the rectangle. Now you might notice the length of the rectangle is the distance wrapped around the circle. Okay, but we've just laid it out. We've just rolled it out into a line. So remember, the distance around the circle is the circumference. So this length here is the circumference of the circle. So the area of the rectangle is length, which is 2 pi r, times the height. So when you put this and add it to this and add it to this, it gives us the area of a circle. Oh, sorry, the area of a cylinder, which it says here. All right. Now, further to that, and you can see here from our formula, we've got two lots of circles, and then that's our curved part, which is from our area. Now, not every cylinder you work out is going to have a closed top and a closed bottom. If we had a cylinder which was opened at the top but closed at the bottom, like a cup or a barrel or something like that, then you need to look at your formula and say, well, what don't we need? Okay, do we have the curved part? Well, yes, we do. So the surface area would be the curved part, but it'd also just be one of the circles. So the formula would be pi r squared plus 2 pi rh. If the cylinder had no bottom and had no top, so it was like a pipe, then we wouldn't have any ends to the cylinder at all. It'd be hollow all the way through, and we just have to work out the surface area of the curved part, which is our 2 pi rh. So you're going to read your questions very carefully to see what makes up your cylinder. Is it closed? Is it open? Or is it a pipe all the way, clear all the way through? Okay?